Friday, we talked about distance formula, midpoint formula. The last problem we did was about triangles, right? We had 3 points and we found the distance between all the pairs of points, and that told us what kind of triangle we have. There's one more definition you need for this section, and it is collinear. So points are considered collinear if, this is the formal definition, the distance between A and B plus the distance between B and C equals the distance between A and C. So that's a fancy way of saying the points all lie on the same line. That's what collinear means. They make a line, all three of them. And the reason that they give you the definition like this, let me draw a little picture that kind of shows you what they're talking about. Let's say A is over here and C is over here. B is somewhere between them. Okay, so all three of those points lie on the same line. And if you look at their distances, the distance between A and B, the distance on the left, plus the distance between B and C, the distance on the right, equals the total distance between A and C. So that's what we want to really remember from this, because we're not always going to have a picture. And even if they look like they're in a line, we don't necessarily know that for sure just by looking at the picture. We want to remember that the two smaller distances add to the larger distance. So I would write that down, okay? So 3 points are collinear if the two smaller distances add to the larger distance. So we're not going to get too hung up on like where A is and B is and C is, because I can reorder those and call them whatever I want. I can call C the point in the middle and B the point on the left and A the point on the right. So the A, B, and C thing's not super important. We just remember the two smaller distances add to the bigger distance. Okay. So let me give you an example. On Friday, we used points D, E, and F. Okay, and this is what you should have in your notes already from Friday. The distance between D and E was rad 68, which we broke down to 2 rad 17. The distance between E and F was rad 34, and the distance between D and F is rad 34. And we determined that this was an isosceles triangle on Friday. Now we want to know, is this collinear? Are these 3 points collinear? So the question is, do the two smaller distances add to the larger distance? So as far as our set here goes, does rad 34 plus rad 34 equal, I'll use the one that's not broke down, rad 68. Does rad 34 plus rad 34 equal rad 68? Use calculator. Do rad 34 plus rad 34. Get a decimal. Do rad 68. Get a decimal. Compare the decimals. The two smaller distances do not add to the larger distance. So they are not collinear. And ask yourself this question. Could it make a line if it made an isosceles triangle? That doesn't make sense, right? It's either going to be one or the other. It's either going to be a triangle or it's going to be a line. It can't be both. Rad 34 plus rad 34, if mathematically you wanted to combine those together, the answer would be 2 rad 34. That's how we add square roots together. They have to be the same square root, and then we have 2 of them in this case, okay? And that's not equal to the square root of 68. 2, if I square it, I get 4 times 34, which would be, what is that? 136 or something would be under the radical. It would look a little different, okay? All right, any questions on what it means to be collinear? All right, so last couple of examples we're going to do together are going to look like this. We're going to be using our distance formula to find a variable that's missing. And it might be part of a point or it might be a distance that we're looking for. So we're going to start with this one. I promise you will see Math Excel questions like this, and I promise these will be the hardest on Math Excel, so make sure you write them down. All right, it says find x such that the point x7 is 5 units from 5, 4. So we can definitely draw a picture just to visualize it if we want to. I don't feel like that's going to be super helpful in this example. When we say something is 5 units from something else, what is it? What's 5 units? It's a distance. Okay, so we know the distance and we have 2 points. So we're going to use our distance formula. Remember, our distance formula looked like this. Distance equals, and then we had, I'm not even going to fill all this in right now, something like that, right? And in the middle, we subtracted our x's and we subtracted our y's. Yeah? So we're going to fill in everything we know. Our distance is 5. Then we're going to subtract our x values. Now, one of them is just going to be an x. So x minus 5 squared. Then we're going to subtract our y's. 7 minus 4 squared. Okay? And now we have to solve this square root equation. The first thing that I'm going to do is that square root is gross. So I am going to square both sides of my equation. On the left, 5 squared gives me 25. On the right, the square and the square root are just going to cancel. So we're going to be left with x minus 5 squared plus, can we simplify that? 7 minus 4 squared. Just order of operations, right? What's 7 minus 4? 3, square it, 9. Okay, that looks better. I only have one x in this equation. It might be tempting to want to FOIL, because can you FOIL here? Yes. But if you do FOIL, then you're going to have an x squared and an x, which means you're going to have to factor again to be able to solve this. So you're making more work for yourself. If there's only one x, get it alone. How do I get this x alone? Subtract 9. Move the 9 over. So I'm going to have 25 minus 9, 16 equals x minus 5 squared. Now if I want to get the x alone, if I want to get inside that parentheses, I need to get rid of the squared. How do I get rid of the squared? Square root. Both sides. On the right, just gives me x minus 5. On the left, you have to be careful. We took the square root of 16. There are 2 answers, plus and minus 4. What's my last step to get x alone? Add 5, and you can put it in front of the plus or minus there, positive 5. And now that's going to give you, you're going to have 2 answers for x. 5 plus 4 gives me 9 is my first answer. 5 minus 4 gives me 1. So there are 2 possible values of x that we could put in that point that would make that point 5 units from 5, 4. If you want to check it, there's a lot of solving stuff here. You can take 9, plug it back in, make sure it gets 5 for your distance. You can take 1, plug it back in, make sure it gives you 5 for your distance. So as long as you've set up your equation correctly, you can plug your answer back in and make sure it works. All right, questions on that one? Okay, let's try this one. A point on the y-axis is what we're finding that is equidistant from -3, 0 and 4, 7. Find a point on the y-axis that is equidistant from -3, 0 and 4, 7. For this one, I'm going to draw a picture just to kind of visualize what's happening here. All right, so here's my axes. This is going to be a very, very rough sketch. Okay. -3, 0 is here. 4, 7 is here. Okay. And our job is to find some point on the y-axis. Okay, we'll fill in coordinates in a second, so that the distance from the point on the left is the same as the distance from the point on the right. That is not necessarily a midpoint. Could it be a midpoint? Maybe if you're super lucky, but likely you're not lucky. Okay, it's not going to be a midpoint. There's just 2 distances that are equal. Now, the nice thing about the fact that it's on the y-axis is we already know half of the point. What do you know about every point that's on the y-axis? X is 0. Okay, so we know the x is 0. The only thing we don't know is the y-coordinate. If we can find that y-coordinate, we're done. Okay, now equidistant means same distances. So that's how you're setting up this equation. You're going to have one distance equal to another distance using our formula. You're going to do the distance on the left between these 2 points and set it equal to the distance on the right, these 2 points. So that's how we're going to set up our equations. So the one on the left, okay, so this guy here, color coded. Subtract my x's, -3 minus 0, and square it, plus subtract my y's, 0 minus y parentheses squared. Okay. Equals, and now we're going to do the other distance, the one on the right. So that's going to look like 0 minus 4 squared plus y minus 7 squared. All right, so we know they're equal distances. We got it set up. If we can solve for y, we're done. Just like the last problem, first thing I'm going to do is square both sides because I don't like that square root. And if I square both sides, what's going to happen here? Are both of my square roots just going to disappear? Right? Because I have a whole square root on each side. So if I square both sides, the square roots are going to be gone. So square both sides. Square this side. Square this side. Square roots disappear. Okay, quick and easy. Then we can simplify a little bit. -3 minus 0 gives me what? -3, square it, 9, plus 0 minus y is -y, and then square it. Now remember, to square something, you're multiplying it by itself. So when I say -y squared, I mean -y times -y. What is that? Positive y squared. Okay, that's the left simplified. 0 minus 4 squared gives me -4 squared, so positive 16, plus, and now we're in trouble, right? Y minus 7, we can't simplify. I've got another y that I've got to deal with, so we have to FOIL now. If you need to write out when you FOIL, this was one of the things you guys had to do on your skills test, this parentheses twice. Y minus 7 times y minus 7 is what we're doing. And then you do first, outside, inside, last, and then combine your like terms together. I am not going to do that every time we see a foiling problem because that would just be like every single day in this class. And I'm assuming if you're in this class, you already know how to FOIL, okay? So my first terms are going to be y and y. That gives me y squared. My outside terms will be a -7y. My inside terms will be a -7y. If I put those together, that's a -14y. My last two terms will be a -7 and a -7. That's positive 49. Okay, now we're going to solve this equation. It's a quadratic, meaning there's a square there. If you have to solve a quadratic, the first thing you should be doing is getting it equal to 0, everything on one side, because then you can factor it or whatever you need to do to solve. So first thing I'm going to do is subtract y squared on each side to get my y squareds together. And here, my y squareds actually just cancel. So I'm left with 9 equals 16 minus 14y plus 49. Do I have a quadratic anymore? Do I have a squared anymore? No, I do not. So I don't have to get it equal to 0. I can just solve for y now. I have a regular old linear equation. If I put 16 and 49 together, I'm going to get 65 minus 14y. If I subtract 65 over to the other side, -14y equals -56. And then last but not least, divide both sides by -14. The one and only answer to this problem is y equals 4. Could you plug 4 back in here and make sure the distances are equal? Yes, as long as you set up your equation correctly, you can plug it back in and make sure it's solved correctly. If this is a problem in Math Excel and you type in y equals 4, it's going to mark it wrong. Why? Well, sometimes it'll already have the x equals y equals. Let's say you just put 4 in. It's still going to mark it wrong.
Because it's not a point, you have to put 0 and then 4.
Yeah. So make sure you're really careful with what it's asking for, because that can get kind of frustrating when you're doing especially online homework. This said find a point. We already knew half the point. The x was 0. We solved for the fact that the y was 4. That's how you would type your answer in Math Excel as a coordinate. And if you typed in just 4, it would probably give you like a little hint saying, don't forget to type a coordinate as your answer or something like that. All right? Questions on that problem? All right, those are probably going to be the two that are the trickiest when you get to your homework. All right, so with your partner, I want you guys to get a half sheet of paper. This is going to be an exit ticket today. Okay, so with your partner, you guys can complete this problem, put both of your names on the paper, put it on my desk when you're done, and then you guys can start on your homework after that. You guys are working on the 2-1 Math Excel, and it is due on Wednesday night this week. Oh yeah, circuit training. If you have a circuit training and you didn't turn in already, circuit trainings were due today. So make sure you put them in the tray in front of my desk, Series 5 tray, and then the new ones are available underneath that stack of posters right now. So if you want the new one for next week, it's there. Yeah. Do one together. Do one together with your partner. You guys can share a half sheet with another group. Put both of your names on your one half sheet. Yes. You did 7 minus 5.
But then in this one, we did it wrong.
Right. So I mean, either way. Now this we can like work harder. We can kind of like do that. Like I did 7 minus 5. So I think I want to roll that out. That might be better. Y minus 7.
Yeah, I was just confused if you had to do it the same way.
Points left and right. You're going to turn in one paper for 4 days, right?
Did you square the 12? Yeah. I think I did it the same way you did it, but like one from when the oil was alive, like minus 7, and that's not there. 7. I've always been. I did, but I don't even. Yeah. Yeah, that's what I'm saying.
But then it would just make this go back to the
Honestly, I don't think this my other way, yeah. We're trying. Yeah. Wait, now, yeah. Wait, when you choose have like this, okay, so. That's, okay. Alright, so you have this, and then you like go like this.
Make sure you guys are leaving exact answers. Exact answers.
I think that's.
This would be down here from this town.
Decimals are not exact answers if you have to round them. Right?
Or. Wait, so you might just look this way.
Yes, in the second, on the bottom.